Hi guys, Audrey here. So today we're going to work on finding a consistency condition. So here we're given a system of equations and we want to find the value or values of k such that the system has a unique solution, infinite solutions, or no solution. So our step one of this type of question is that we want to stick it in a matrix. So I'm going to take this and stick it in a matrix. K minus 1, k minus 2, k minus 3, 0, k minus 4, k minus 4. Okay, so turns out this is already in REF, row echelon form. And that's all we need when we're counting solutions. So we need to have, our pivots don't have to be 1 and we don't need to have zeros above them. So in other words, this k minus 2, I don't need to make it 0. And that's a good thing because I can't make it 0 because I am not allowed to use k itself as a pivot. Okay, so what that means, this is REF. Now what we've said is that when we have the matrix in REF, the first thing we should do is check, is there an obvious contradiction? So obvious contradiction. And our obvious contradiction would be if we had 0, 0, and then not 0. So when we say obvious contradiction, we're looking for something where there are already zeros across. So are there zeros? Is there a row of zeros? There isn't. So in this particular problem, there is no obvious contradiction. I just spelled none wrong. None, because no row of zeros. So then the next thing we do is we say the only problems, the only time that I could possibly have infinite solutions or no solution are when I don't have a pivot in every column once we've gotten rid of the obvious contradictions. So what we do is we look at the places where k shows up in a pivot position. And we want to plug those values into the matrix to see what happens. So what that means is this k minus 2 here and this k minus 3 right here, they're actually not all that important in terms of finding a consistency condition. We might have to deal with them a little bit in a second, but they're not values I'm going to plug in. So the first thing I have here is k minus 1 is in a pivot position. So when does that equal 0? When k is equal to 1. So I'm going to plug in that value. So that gives me a 0 here, a 0 here. 1 minus 2 is negative 1. 1 minus 4 is negative 3. So that's still a negative 3. And then 1 minus 3 is negative 2. Now notice, now that I've plugged in this value of k, this is actually not in REF. I don't have a pivot in every column. I have that first column that doesn't have a pivot in it. My second one, my second column, because there is no pivot in the first column, my pivot here is that negative 1. So I can't actually count the solutions just from looking at this. I'm going to need to finish the row reduction. So here, I'm going to do row 2 minus 3 row 1. And that's going to give me 0, 0, minus 1, minus 2, minus 3. That's going to make me my 0, minus 3 times minus 2. That's minus 3 plus 6. That gives me a 3. And what just happened? What just happened is a contradiction. That contradiction was really not all that obvious, but it did happen. So there is no solution when k is equal to 1. Now the second pivot position that we have here is k minus 4. So next we're going to say, when does k minus 4 equal 0? Well, that happens when k equals to 4. So I'm going to plug that in. I'm plugging it into my REF form of the matrix here. So 4 minus 1 is equal to 3. That's 0. 4 minus 2 is 2. 4 minus 3 is 1. 4 minus 4, well, that gives me a 0 here. Notice, this matrix is in REF. I've got my pivot in the first column. It's got the 0 below it. I have a column without a pivot. And I've got that no contradiction occurs. So this, we don't have a contradiction, but we do have a column without a pivot. So this represents infinite solutions. Okay, so these are the only possible ways that we could have ended up with a column without a pivot. If k is equal to any other value, let's say that k is equal to 2, for example, then I'm going to have that first k minus 1 is going to be a pivot, that second k minus 4 is going to be a pivot, we're going to have a pivot in every column, and we know that that represents a unique solution. So my unique solution happens at every place that we didn't check, because those are the places where I have a pivot in every column. I remind you, a pivot is any number other than 0. Pivots can take on any value in the whole world. They don't have to be 1. They just cannot be 0. So this is, we have a unique solution when k is not those values. We have infinite solutions. Well, that came up in the case when k was equal to 4. And we have no solution in the case where k was equal to 1. That's all. All right, bye guys.